So what we were discussing last class, we looked at dot product, right, and cross product. All right, let's all of you take this quiz. Okay.
Okay.
So you have this. Just do it on a single sheet of paper and see if you can do it. You have A equal to okay. Now tell me what is A dot B. Quickly refer your notes and tell me what is A dot B. Value. Value. Calculate the value and tell me.
I'm sorry.
Tell her. Good. A dot B. Where are your notes? We had a. Okay. It's a quiz, yes. You can look into your notes. That's okay.
Would it be negative 18, negative 35?
A dot B. What is A dot B?
6 times negative 3 plus negative 5 times 7.
Do that and tell me.
Okay.
Yeah, just don't tell me the answer. Just do it.
Can I use my calculator?
Sure. You can use calculator, notes, everything is fine. And tell me what is A cross B.
Is it 19?
Just write it and give it.
This one,
Yes.
negative 18, negative 35, 72. Transpose.
No, not transpose. Dot product should result in one number. Dot product cannot result in vector. This is a vector. A is a vector, B is a vector. A dot B results in one number. It cannot result in another vector.
19.
Yes. Just write that and give it to me. Just show me how you have done it.
Are we going to try to save it? Oh.
Do the cross product now. You have your notes? How do you do the cross product?
It's 7 times 8 plus.
No. How do you? So let's.
You stretch out the eyes and then determine it basically.
Right. Yeah. So do the determinant and show me. So you can do the IJK if you would like. Okay. You guys look at the notes. Write for you if you'd like. I, J, K, minus 3, 7, 9, 6, minus 5, 3. Okay. All you need to do is to take it, determinant of this. Done. Unity. Determinant, how do you take determinant? So it's
You press like this one.
this minus this, or this
Oh.
minus.
Oh, mine is not plus. Okay.
So this is like this minus is this.
Okay.
Done? Alright? Got it? So you have how you take it. write your names, okay? Alright. So now what you should do is just go back and see if you can do the MATLAB of this. Okay, it's very simple. And MATLAB is going to be available on machines in the flight lab. So this is A dot B is simply negative 18, 35, right? So this is equal to, and this is equal to. So what you have here is, now just pay attention here, everyone. It's I into, you leave this column and this row, right? So it's 7, 8, 56 minus 45. Got it? You have negative here. Okay. Then you have, for j it is minus j. So you do this, right? Minus plus minus. So minus j is, you leave this row, sorry, this column, this row. You have minus 24 minus 54. Got it? And then you have plus k. You have 15 minus 54.
And you said we was left like the cap off the K of the other line, that would be wrong, right?
Right. So you have to make sure now, how do you write it in this form? So you have A cross B is equal to, how much is this? 101 plus 78. This would be 39.
I don't think I did that right.
7 2 7.
Yeah. Okay.
Got it? So this is how you write it, right? Because it's been given to you in this form. Right? There's a T as well here. Okay.
You don't have to put in the IJK.
That would be wrong.
Yeah.
You can put in the IJK. Now, the reason I did not put IJK, why did I not put IJK?
Because the train, I don't know.
Because of
There is no reference here. It could be IJK, XYZ, ABC, anything, right? So that's the reason you give it independent of that. You can put it, you just do it with ijk for your convenience.
Okay.
But you can, when you give me the answer, it's, you have to, either you assume it's the same basis as this, right? Or you just write there it's the same basis as this. The ijk is only for your convenience, so that you can calculate. Alright, this is something you should know. If somebody wakes you in the middle of the night, you should know how to do this. Okay? Now what we so we have discussed dot product, cross product. There are triple products. There are two triple products. One is A dot B cross C. Okay?
Oh, come on, you get spicy.
And this is equal to B dot C cross A is equal to C dot A. Now look at how it is rotating cyclically. Can you see the cyclic rotation? You have A, B, C, right? So A has gone here, B has gone here, C has gone here, right? This cannot be equal to B dot A cross C. This is wrong. A cross B is not equal to B cross A. Okay. However, A dot B is equal to B dot. This is okay. Okay, so you have to look at the cyclic this thing, and you'll be required to use the cyclic. This is called the scalar triple product. Why is it called the scalar triple product?
So we only want to have directions. I mean,
No. If you look at A dot B cross C,
we're gonna get one number.
yes, the output of this is a scale. Right? This will be one vector, and when you do the dot, you get a scalar. The outcome is a scalar. Then you have the vector triple product. So this is scalar triple product. Vector triple product, which is A cross B cross C. Okay. Here we use something called the back cab rule. You have to remember back cab, back minus cab. So what it means is B this is the back cab rule. So if you see here it is A, B, C, A cross B cross C, right? So back is B, A, C, back. Okay, B, vector B. This, what will this be? A scale. Okay. So this will be, what is the total outcome of this? Is this a scalar or a vector?
Scale.
It's a vector. Why would it be a scalar?
Is that number?
This dot product will be a,
Oh, yeah, okay.
so this vector will remain. Here vector will, it will result in a dot product. So here, this is a, the outcome is a vector. So this is called the vector triple product.
So,
Okay. You have to just remember, this is another way of solving this. If you have this, you can solve it like this. And you will be given some assignment problems where you will be required to use this back minus cab rule, okay, and apply it. Can you do it? Yes.
So the relationship between dot product of A and C and B, is that also using the dot product?
A, B, and C, we have all over the
The relationship between
Where it says back B A C before the parentheses, is that
That's a
are you
big.
using the dot product or the product?
here,
Yes.
it's
It's
multiply.
not.
Both.
So here is this thing. A.
I did A by 19.
All right.
Yeah.
This is okay. What this means is this vector B is multiplied by the scalar A. Okay. This is not okay. This is not defined. You cannot multiply vector A with vector B. This operation is not defined. This operation is also not defined. You cannot divide a vector by another vector. Okay? This is okay. You can divide this. So what's happening here is this. What does this result in?
A
Julian?
scale.
It results in scalar. So you're multiplying a scalar by
A vector.
a vector. That is okay. Okay. So this is a vector. Vector minus vector is another vector. Okay. How do you do vector minus vector? Huh? If you have A minus B,
You just do
huh? Do the components minus 3, minus 6, those components. Okay. So you have resultant of vectors. So if you have a vector A and a vector B, right? This is called the tail of the vector. This is called the head of the vector. Okay. So if you want A plus B, what do? You do this A, and you take this and join it here. You join the tail of B to the head of. Okay. So you have A, B. A plus B is this way. Got it? So this is the parallelogram law of vectors or the resultant vector. You take the tail of vector A and join it to the head of vector B. This would be the result. Got it? So if you have, what is A minus B?
The tail of A.
Huh?
Is the tail of A. A minus B would be the tail of A.
A minus B would be what?
Would be the tail of A.
Tail of A.
Connect the tail of A, B to tail A.
You would also connect the tail of A to tail of B.
So what you do is, if this is B, what is minus B? Opposite direction. So what you do is, this is your
Oh,
minus B, right? Because what has happened is I have kept the magnitude the same, the direction is
the changes.
opposite. Now you join this. This is A minus B. Got it? So it's simply adding this vector and this vector. This vector just happens to be minus B, the opposite, because the direction has changed. Got it? So you have to just change the direction and figure. Okay, this is the resultant of vectors, and Let's take a little bit look at kinematics. Before we get into kinetics, now keep in mind this is all review. You are expected to know this, okay? So kinematics, you have, let's say you have this reference frame, okay? You understand a reference frame? So whenever I talk about reference frame, think about this classroom and think about this as the origin, this corner as the origin, okay? Which is the x-axis, which would be the x-axis. This would be the x-axis, okay? This would be the y-axis. So what you have is, always understand this right-hand rule. X, everybody do this? X, yeah. Only one finger? Jared, only one finger? Right hand.
Put your thumb down.
X, one finger. Okay, this way. Here. X, Y, and Z. It has to be this direction. Okay? You got it? X, Y, Z. Got it? So you can change this anyhow you want. So if this becomes X, this becomes Y, the Z will go down. Okay? If this becomes Y, this becomes Z. This becomes X. It should cyclically rotate. Y, Z, X, Z.
So it's in a cycle, so that was Z, and other will be X.
Right. So you have Y, Z, X. And you have Z. What is this? X, Y. So you have to always keep that cyclic rotation. Okay? So if your Y goes this way, your Z has to go down. Alright, so now what is the X direction here?
The line going towards the
This is the X direction. Okay, this is supposedly coming out of the board. And you have this position vector. Everybody understands the position vector? What is the position of Michael? So let's look at the position of stay still. This. So if you look at that, it would be how will we figure out the position from this axis? We will say so many units in the x direction, so many units in the y direction, and so many units in the z direction. So that would vector would be, if I want to draw that single vector, I would say take a line from that corner and put a vector till this point, right? So that is that vector. You get it? Everybody gets it?
Yeah.
Right? So that is that vector. Now let's say Michael starts moving around. What's going to happen? That point is going to start moving around, right? It will have a velocity, it will have a acceleration. To have velocity, there needs to be an acceleration. If you're still, there has to be acceleration. So R, how do you write R in terms of this? You write Rx I plus Ryj Rz k. Okay. So this I, J, K are the x, y, z components of that. This is the position vector. Okay. Now if you see, this reference frame is fixed, right? So what you can do is, when you take, what does that mean? If you want to take the derivative of this, if you want to figure out the velocity, you would do r d over dt of r is equal to what? Are this ijk changing?
Where, as, no, this big,
No,
right?
Ijk is not changing, right? If they were actually changing, what you would have done is, you would have done this. Rx dot I plus Ry dot J plus Rz dot plus, you would have done
The,
R into I dot, but that is not changing. So that dot, I dot is 0 because it's a constant. Okay. Now what is this? This is velocity. Okay, and this is only translational velocity, because we are talking about, that is the tip, right? So when we talk about orbital mechanics, we are talking about, there is always, how many degrees of motion are there in free space? How many degrees of motion? 6. So 3 translational and 3 rotational. So we mostly discuss, we first discuss the translational degrees of motion. Okay. So here we are talking about the tip of that. So that is, a point doesn't have any, it doesn't have any orientation change. Okay. If it is just a point body, it doesn't have any orientation change. So in that case, we are talking about only, this is only translation motion. Right? So your Rx dot, Ry dot and Rz dot, the components are changing. Okay, so now what is this? Vx I, Vy j, Vz k. Right? So this Vx is Rx dot, Vy is Ry dot, Vz is Rz dot. Right? Now if you take this derivative of V, what are you going to get?
V dot,
Vx dot I
V
plus Vy dot j plus
okay.
Vz dot k. Okay, and this is acceleration, and this is equal to, we can say this is ax I plus ay g. So these are the ax, ay, az are the acceleration component. Alright. Now what you should know is, why is this kinematics? This is kinematics. You are describing the motion in a reference frame. This is essentially kinematics. Why is this kinematics?
There's motion.
Huh? Huh?
There's no forces.
There is no forces. We did not talk about any forces. We are just describing the motion in terms of mathematics, the derivative of vector. We just use vector and we are saying how it moves. That's it. Right? So that is the reason we are not discussing force. Now when we start discussing force, what does it become? Kinetics. Right? And when we talk about kinetics, we invariably talk about force, but what are our guiding principles for kinetics? Huh? Guiding principles for kinetics? Nia, come on, don't be silent. Yes, Newton's law of motion. So you have, when you talk about kinetics, we talk about mass, force, and Newton's law. What relates this mass and force? Which law relates this? You guys remember? Huh?
You said which law?
Which law relates mass and force?
Second.
Mass and force.
Sorry.
The law of universal gravitation. That is the most fundamental Newton's law is the law of universal gravity. Even though you're right, it relates, but it relates in reality it relates force and
Force and mass.
momentum, change in momentum, linear momentum. Okay. So Newton's law of universal gravitation. What does it say? Anybody knows the statement? Remembers the statement? Right, so every body is attracted to every other body. There's a force of attraction between any two particles or any two bodies, and the force of attraction is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Right? So that is okay. So you must remember this. Everybody understands mass. Mass, what is mass? Huh? So when gravity is involved, what does it become?
That's weight.
That's weight, right? So mass is
Weight over and acceleration. Weight over gravity.
density times volume, but it is the total. That's right. But it's the total constituent of something.
The whole.
The constituent of something. So you have this Fg is equal to G m1 m2 divided by
Wait, I remember seeing this.
right. So this is that. Okay. So here what is this G? G is the gravitational parameter. Okay. M1 and M2 are the.
F sub G is equal to
So F sub G is a force. There is a force of attraction between. So you talk about this M1. Alright, silence. And this is what is this? R square. So there is a force of attraction between this body and this body. Okay. So this is your Newton's law of universal gravitation. Okay, this is where it all started. Okay. Now, for orbital mechanics, what we do is see when we're talking about this M1. This M is the mass of large object, okay? And this M is mass of small. And here, this M is much greater than small. That means you can just, this, if you write this as G M over R square. So what happens is this can be written as so you have this W can be written as GMM divided by R square. So this can be written as M G So this is how you define your wave. Okay. Now this G is constant. Do you weigh Does your weight change when you go from one planet to another?
Yes.
It changes, right? So now see what does mass change when you go from one planet to another? Mass doesn't change. So this G and G is a property of the object which you are on. Okay, this in our case this is Earth. This is the mass of Earth. This is what is this R?
The
The
radius.
radius of Earth. So these are all constants, right? Assuming Earth is a perfect sphere. So, but in reality, this R keeps changing, right? When if you climb a mountain, the altitude keeps changing, right? So, but this is that WMG. This weight is nothing but the force experienced. Okay? And Newton's laws of motion. We'll wrap up with Newton's laws of motion. Alright. What is Newton's first law of motion? Huh? Right. An object in motion stays in motion or
Let's context about equal opposite.
huh?
And let's context about equal opposite.
No.
That's
You're mixing something. Right. An object in rest or in motion continues to stay in rest or in motion unless affected by an external force, not equal opposite. Okay? So it's called the first law is called the law of what is it called? Not law of inertia, right? So that state of rest or state of motion is inertia. Okay? So this is the first law. Alright, you guys have to stop. No laughing, okay? Please. Be serious. What is Newton's second law? So this is, everybody please understand, F is not equal to ma. Don't say that as an aerospace engineer. So Newton's second law states that an external force results in change in linear momentum. Okay, that is the complete this thing. F is equal to d over dt of mv. This is a complete Newton's law. Always remember this. You cannot say F is equal to ma as an aerospace engineer. That is not acceptable. You cannot explain how a rocket is launched, how a launch vehicle is launched if you say F is equal to ma. That is an incomplete version. So if you take the derivative of this, what you're going to get is d. This is m a, right, plus m dot v, right? This is a complete form of Newton's law, Newton's second law. So what is happening is this, in many cases m dot is 0 and m is not changing. So you can assume that m dot is 0. But for a launch vehicle, is this m dot 0? There is a negative mass. There is mass loss. M is changing for a rocket. That results in thrust. You should understand how a rocket gets launched. How will a rocket get launched? Why does it go up? Huh? Huh? If it burns fuel, where does it say it should go up?
It's due to the force when we burn the fuel.
Where is that force created? How is that force created? Huh? But you are just burning mass. That should not create. That is just energy. Why is it getting converted to force? What is it connecting to thrust? But that is direction. But where is that thrust coming? Where is that thrust coming? So this is where see what is happening is, you look at this equation, okay? When the rocket is is on the ground like this, and when it pushes the fuel down, or when it pushes the fuel down, there's an impact from the ground that pushes it up, but that does not keep it going up. The reason it keeps going up is because there is mass loss happening. Mass loss is happening, right? There's mass loss. Fuel burning is what? There is rapid mass loss. If you look at a solid booster, this m dot is losing. You're losing m dot. When you're losing that m dot creates a force, which is the thrust. And this is how Newton's law is explained. How you explain the launching of rockets. If you don't know this complete form, you cannot explain the launch of rockets. What happens in space when the thrusters are fired? How does a rocket move? How does a satellite move? You've seen Gravity, right? Have you guys seen the movie Gravity? Okay, so when the space station has to move away, you have seen that ad when the space station tries to move away from an incoming this thing. So the space station has thrusters, right? Why does the space station have to move when it fires a thruster? What are thrusters? You're not burning anything there. Can you burn anything in space? Why can't you burn anything in space? No oxygen to burn anything in space. So you are not burning anything. So where is that thrust coming from? Somebody just said if you burn fuel you get thrust. But where you're not burning anything in space. Mass loss. You're just throwing out mass. When you throw that mass out, that results in whatever direction that mass goes. The mass loss creates thrust or force. Force is nothing but thrust, and that thrust pushes it away. Got it? So this you have to remember. And what is the final law? Law of action and
Reaction.
so now you have to keep in mind, don't mix this law and this law.
Okay.
Never. Okay? So what does the law of action and reaction say? Action and reaction are
There's one opposite.
equal and opposite. Always. Okay. Alright, attendance sheet please. Now if you come late, you're going to miss if you come late, you're going to miss the quiz, and if you miss the quiz, you're going to miss points. So don't come late.